Hello, I'm Jeff Hill, the creator of the Tuatara side-by-side. And what we have here is the all-electric model E-Toara. And the purpose of this video is just to explain the features and the operation of the vehicle for first-time operators. The first thing that needs to be understood by new operators is that a fully electric off-road vehicle operates differently from that of the combustion engine equivalent. By way of example, you wouldn't drive our 5-speed petrol Tuatara up a steep incline in high gear because it would stall. On the other hand, you could drive our E-Toara in high ratio up the same incline, and you might think that was okay, but it's not okay. E-Toara is fitted with a high ratio and low ratio setting for a reason. If you're travelling up a even modest incline, you do need to select low ratio. This is because using high ratio to travel up a modest or steep incline uses a lot more amps, and this equates to higher battery and motor temperature and a reduction in range. Now I want to talk about the operation of the E-Toara for the first time. Now the first thing that a first-time operator needs to do is to thoroughly read the operator's manual. Now the operator's manual has all the information about the features of the Tuatara and its operation, as well as a lot of useful information. Now that you've read the operator's manual, you are nearly ready to operate the vehicle for the first time. But the first thing that you need to do is to do a walk around of the vehicle. What you're looking for is any damage that may make the vehicle unsafe to drive. But you'll be also looking at the tyres, making sure that they're fully inflated, they're not flat. Okay, having walked around the vehicle, there is just a couple more things that we've got to do. So firstly, if you lift the front tray, check the brake fluid reservoir. Fluid in the reservoir should be at a level immediately below the filler spout, as it is here. So now we'll just walk around the other side of the vehicle. We need to check the radiator. So you just remove the pressure cap, and the coolant should be approximately 10 mils below the base of the filler spout. Okay, now we're going to get into the driver's seat of the vehicle, and the first thing I want to talk about is the operation of the handbrake. The handbrake will already be on, so we'll just release that, and now I'm going to reapply it. Now, when you apply the handbrake, the first thing to do is to put your foot firmly on the foot brake and then pull up as far as you can with the handbrake lever. Now what this does is when you put your foot on the foot brake, you're actually pressing the brake pads against the brake disc. Pulling up on the lever is actually just taking up the slack with the brake cable. The advantage of this is that you can get a lot more pressure with your foot than you can with your hand, and it's not likely to lead to stretching of the brake cable. So this is a very good procedure for putting the handbrake on. All right, another pre-drive check before operating the vehicle, which you can do in the process of releasing the handbrake, is when you put your foot on the foot brake, you should notice that the resistance increases at a steady rate as you depress the pedal to the point where it won't go any further. There shouldn't be any sponginess, and the pedal shouldn't be able to go to the floor. If either of those two things are detected, that needs to be investigated before the vehicle is used. You would have noticed that there is another hand lever on the dashboard. Now this is the brake pedal lock. Now the purpose of the brake pedal lock is to provide extra retention on steep slopes, or when the vehicle is loaded, or in slippery conditions, when the operation of the handbrake may not be adequate to retain the vehicle. The handbrake works off the rear wheels, as I say. The brake pedal lock works off all four wheels. And how you apply that is you place your foot firmly on, as hard as you can, on the foot brake, and then you pull the lever down as far as that will go, and that will actually hold the brake pedal down. So now you've got the handbrake and the brake pedal lock, all four wheels are locked, so the retention is very good. But the thing that needs to be borne in mind is that the brake pedal lock is hydraulic. It is not something that you can rely on for lengthy periods of time. So if the vehicle is going to be held on a slope with the brake pedal lock in place for periods of perhaps up to half an hour or more, our advice is that the wheels are chocked and also that it's placed in gear. But the bottom line is that the handbrake should be your primary device for retaining the vehicle. Now, because this video is directed at first-time operators, what we're going to do now is we're going to raise the deck on the vehicle, and then I'm going to point out to you some of the very important components that you'll find under there. So to raise the deck, turn the ignition on, and the ignition is on now, and then there is a rocker switch here, and you've got a choice of either up or down depending on whether the deck is going up or down. So we'll push the up. Right now you can probably hear the sound of the deck rising. Okay, now that the deck is fully elevated, so we'll just have a look under the deck and point out the components. The first one is the electric motor, which is this unit here. It's a 15 kilowatt unit electric motor, and that's what drives the vehicle. In front of that is the transmission and also the transfer box, and that allows us to drive forward axle and the rear axle. Here we have the motor controller, and that's what controls the motor. Behind that we have the 12 volt battery. Like most electric vehicles, they have a 12 volt battery, and the purpose of the 12 volt battery is to turn on the lithium ion primary battery and also to provide power for all the 12 volt components like the lights and that sort of thing. In the corner here under the seat, or on both corners, there are the battery packs. These are lithium ion battery packs. They are the main power source for the vehicle. Immediately under the middle seat here, and it's jutting out into the rear, that is the onboard charger, and that's what charges the lithium ion batteries. Okay, so now just getting back into the cabin, there's a few things that we need to do. The first thing is to check the position of the steering wheel. To move the steering wheel, you just pull, there is a lever here on the steering column, and you just pull that towards you, and then you can simply move the steering up and down depending on your body type, so you need to be comfortable. We also need to check the rear vision mirrors. Make sure that you've got a good view behind you, and don't forget the internal one as well. You also need to put the seatbelt on. The seatbelt is a sash type seatbelt, plugs in to the receiver here. The important thing to do is once you've plugged it in is just check and make sure that it's secure. Now this seatbelt also controls the operation of the vehicle in the sense that if you don't have your seatbelt plugged in, the vehicle won't move. Okay, so now we're going to look at the main gauge. Now the first thing we're going to look at is the SOC. Now the SOC is the state of charge. Now in this case it's 92%. It must be more than 20%. If it's less than 20%, the vehicle needs to be charged before it's operated. The reason for setting the lowest threshold at 20% SOC is simply because it provides the best protection for the battery. So we recommend that it isn't discharged below 20%, and immediately it gets to that level it should be recharged. I also want to refer to the VIN, or the voltage in. Now this should be at least 13 volts when the vehicle is first turned on. In this case it's 13.6. Now what this is telling us is that the 12 volt battery is being charged by the lithium battery. If it drops below 13, it needs to be investigated. You can have a situation where the 12 volt battery is not being charged, and as I indicated earlier, the 12 volt battery actually turns on the lithium battery. So if it's not being charged, it will discharge over time, and you could be stranded in a paddock somewhere and you've got a long walk to look forward to. So it's really important when you first start up the vehicle in the morning is to have a look at that and make sure that that is being charged. It must be over 13 volts. Okay, so two other readings on the gauge that you need to look at when you first start the vehicle is, one is the motor temperature. In this case it's 21 degrees Celsius, and also the battery temperature, and in this case it's 15 degrees Celsius. Now In the case of the motor, anything up to 80 degrees is satisfactory, although at 80 degrees it's getting warm. And with regard to the battery, anything between 0 and 55 degrees Celsius is within the range as well. So anything outside of those temperature ranges needs to be investigated. Don't operate the vehicle if those ranges are exceeded. Now, with regard to the 12-volt battery, the charging from the lithium batteries, that's not the most efficient system, in the sense that an alternator on a combustion engine, for instance, is much more efficient than this. And especially with the low speed running with these vehicles, it is possible for the 12-volt battery to discharge to a level where it hasn't got sufficient voltage to recharge, to start up the lithium battery and therefore drive the vehicle. So what we recommend is, say, the first of every month is just putting the 12-volt battery on a trickle charge. Okay, now probably the most important reading on the gauge is actually the amp meter. The amp meter is akin to your rev counter on a combustion engine vehicle, and the red line 300 amps. So at the moment there is no reading at all, you've got zero reading, but as you put more pressure on the vehicle, like you go up a steep incline, towing a trailer or something like that, you'll notice that that amp meter will climb. If it gets up towards 300 amps, you're in high ratio, you need to adjust it down to low ratio and keep your speed down. You need to bear in mind that prolonged running at high amperage over 300 amps can result in the vehicle going into self-protect mode. And what it will do when it goes into self-protect mode, it will shut down. You need to turn the ignition off and turn it back on again to reset it. Okay, so the E-Toara is equipped with both two-wheel drive and four-wheel drive. Two-wheel drive works off the rear axle and four-wheel drive works off the front ones. Now, in all likelihood, you'll find that two-wheel drive is satisfactory for most instances. The only time that you'll need to use four-wheel drive is where perhaps it's a very steep incline, you're towing a trailer, you've got a lot of weight on board, and you want to ensure traction. Bear in mind that four-wheel drive will use more battery, but in the case you do need to use four-wheel drive, there's a rocker switch here, and all that's required is first to bring the vehicle to a complete stop and then simply activate the switch, and you'll hear a little whirring sound as the motor ticks over and engages four-wheel drive. Once the need to use four-wheel drive is no longer there, my advice is that you revert to two-wheel drive. The vehicle operates a lot more efficiently, quieter. Okay, so here we have another really important feature of the E-Toara, and that is the diff lock. These are the levers for the diff lock. We can engage the front axle independently, likewise the rear axle, or we can engage them both at the same time. Once they're engaged, you'll see that there's an icon on the dashboard which shows an X depending on which axle is engaged. It's really important that the diff lock is used sparingly because it does put a lot of pressure on the drivetrain, and it should only be used when four-wheel drive is already engaged, and it should only be used when there is a traction issue, where we're losing traction or it looks like we're going to lose traction. And even in those circumstances, what I would suggest is that you engage the rear diff lock first and see whether that is effective. It's only if after engaging the rear diff lock you don't get traction that you then engage the front one. The reason for that is the front one in particular puts a lot of pressure on the drivetrain. You must bring the vehicle to a complete stop before engaging it, and you must keep your steering straight, because what happens is it locks up the axle, it cancels out the operation of the diff, and it will try and drag your wheel straight. So if you turn your wheel, you're fighting it, And what can happen then is it can result in breaking of the CV axle, it could damage the diff, it could damage any of the steering components. So as I say, only use this sparingly. Now, just to explain how the diff lock works and why it's so effective is, what it does is when you apply diff lock, you actually lock the axles. Wheels otherwise, with the differs open, work independently. But when you lock the axle, they work together. An open differential means that the torque is spread evenly between the two wheels. Now, one of those wheels could be getting traction, but it's only getting 50% of the torque. And 50% of the torque is being wasted and going to that wheel that's not getting any traction. So by locking up the diff, it allows all of the torque to be directed at that wheel that's getting traction, or at least to distribute it more appropriately. And that's why it's so effective. If you've got the front differential engaged, keep the steering straight. Don't turn the steering, because that is what is going to result in damage to the drivetrain. So that's very important. Keep your wheels straight, keep your speed down no more than 10 kilometers an hour. Okay, now for those customers that have a glass windscreen installed on their E-Toara, as there is with this vehicle, I'm just going to explain to you the operation of the windscreen. You lift the handle, you then push against the window, and the weight will be taken by the air struts on either side. The purpose of having it open is to obviously allow ventilation to flow on hot days. It can be used by hunters for shooting out of. What we do insist on is that you don't move the vehicle with the windscreen fully open. What you can do instead is there is an anchor point on the handle that allows you to operate the vehicle with the window slightly open. That will give you that airflow. Okay, so now we're ready to move off. We've got the ignition on, the vehicle is stopped, neutral is selected, and you'll see neutral on the gauge here. The vehicle must be in neutral before you select a gear. And now we've got the option of high ratio or low ratio. High ratio would be in a situation where on level ground, for instance, undemanding terrain. Low ratio would be if we were going up an incline, pulling a trailer, a laden vehicle, that sort of situation. So what we're going to do now is we're going to assume that high ratio is our selection. So we put our foot on the brake, release the handbrake, move the drive lever to drive, and simply pull forward slowly. On the other hand, if our first movement is reverse, we're going to select the reverse gear and we'll just go slowly backwards. Changing between high ratio and low ratio is simply bringing the vehicle to a stop, putting it in neutral, and then in this case selecting low ratio. And once again, if you look on the gauge, you will see that the icon there is a turtle. In the case of high ratio, which I'm going to select now, it's a hare. The main thing is bring the vehicle to a complete stop, put it in neutral before changing the gear. If you don't do that, you could damage the transmission. Thank you for watching the video. I hope that it was helpful, and I hope you really enjoy your Tuatara.